I'm going to go into this sheet here. So we left off with raw count and pulse width modulation. Now I'm going to go to pulse width modulation and angular velocity, because even though the pulse width modulation is dependent upon the raw count, the angular velocity is dependent upon the pulse width modulation. Okay, so this is the voltage that's driving the motor. So let's go ahead and insert a chart, and we're going to use scatter plot again. And let's go ahead and label everything first. So this is our angular velocity. Spell that. And this is going to be in radians per second. Okay, and then down here, this is going to be the pulse. So I'm going to go ahead and write this one out. Pulse width modulation. And again, this is going to be microseconds, and I don't really have to, I can just use Alt M again, microseconds. Okay. So now that we have that, let's just let's put a curve on here, and I'm just going to go ahead and add a trend line. So I can right click on the point and add a trend line. And right here, you'll see that we have a linear line, and it looks pretty good. I guess you can say that the equation, or the coefficient of determination, which is right here, is 0.9867. And what I'm going to do is I'm going to change this to see if I can make it look even better. Okay. So I'm just going to go ahead and go here. And so exponential, we can use that. The fit is less. Linear, logarithm. So we have our logarithm here. You can see that the fit is really good right there. Polynomial, the fit is really good there. Power, and then we have moving average. I'm going to go with logarithmic. Okay. And so logarithmic looks like it's fitting pretty good there. Okay. And I'll close that. And I'm going to go ahead and move this chart to another sheet. And I'm just going to call this one PWM and angular velocity. All right, so we'll move that nicely to another chart. And it appears as though this thing would continue to curve over, but this is our math right here. So this would be our math, which is quite nice to have your math produced. And when I say math, I'm talking about your model. So you can model anything. You can model pretty much anything as long as you have your data. Cool. So we have two models. We have pulse width modulation correlated to angular velocity. And I need to write that in there. Correlated to angular velocity. I'll just take my units off in the back here. Get rid of that. All right. Now it's missing this point right here. So even though we have all of this, and I think this is great, we could actually put our standard deviation on that chart. So I can go back to this chart. Which one is it? This is raw count. And then I can go back to this chart, select on it, go to chart design, and then I want to add error bars. So I'm going to go to more error bar options. And when I choose error bar options, I'm going to go to this little bar here, and I want to choose custom. And then I need to specify the value. And so the value is going to be specified on this regression analysis sheet. and I'm going to use standard deviation. So this is positive error value. So that's the positive. That's the top. And then I'm going to have my negative, and it's going to be the bottom. Well, it's going to be the same thing, but it's going to be the bottom, and I'll just say OK. And it reduces those error bars to something that we actually know. So our error bars are our first, this is our first standard deviation, okay? And so the model is falling within the first standard deviation of our measured points. Now, that's great. And the error bars are going to really take shape when we verify this data with other experiments, okay? So I'll just go ahead and say, I'll just stop right there, and we'll go to part 2 after this.